Hello everyone, greetings to all. Today we are starting Statistics 1 for IIT Madras B.Sc. So let's start Stat 1. So basically what is statistics? It is the science of data collection. It is the science of data collection, organization, analysis and interpretation. Basically the work of data scientist is to collect the data and then organize in tabular manner and perform basically various operations on them depending on the ML models we will be studying later. So stat plays a major role as it is the science between the data science. So stat is very much required for the students of data science. That's why we are studying it anyways. So first one is data collection. For data collection there is a website called Kaggle which will be very helpful to us while collecting the data. One of its core feature is explore data sets. Here you can find various data sets through which we want a regular tabular data so we can perform various analysis on it. So Kaggle can help in these type of operations a lot. So Kaggle is not coming in the examination, but for the activity purpose also for stat activities, Kaggle will play a major role for collecting our data sets and performing analysis and operations on them. So remember it. Now comes the main portion from where the questions will come. First one is the branch of statics. Branch of stat. There are mainly two types of statistics. First one is descriptive and second one is inferential. So what is descriptive and what is inferential? Let's start with a simpler example. Consider an exam where there are 10,000 test takers and is a test of 100 marks. There is a test of 100 marks and there are 10,000 test takers. So we took the data of scores of each test taker and plotted on a graph. Then we got a bell-shaped graph as a usual graph that we get in such out of examination. There were no negative marks, so the minimum marks one could fetch is 0 and maximum the one could fetch is 100 as the maximum marks were 100. So when we plotted the data, we found that the maximum marks lies in the range of 20. 20 where the maximum marks came. So we can say that 20 is the mode of the data or the most frequent data. About 700 students got around 20 on around 20 marks in the examination. So the maximum student score is 20. So the maximum student score is around 20. And the inference, that what is the inference we can draw is the test was hard. The test was really hard, so only the maximum marks one could score was 100, but the most frequent data, the most frequent marks scored by the student were only 20. So this was the inference that we drew from this graph. So the process of making the graph or performing statistical analysis, like what is was the maximum score of this student, it was one of the stat analysis. So this comes under the descriptive analysis, and what we draw attention from it, what we draw the inference from it, comes under the inferential statistics. So the red one that I have marked is inferential, and the green one, like plotting the bar graph, no sorry, plotting the graph and then getting the maximum rim frequency of marks, is descriptive. So in a basic definition we got that, but to get further deepen in this concept, we have to understand the difference between population and sample. See, uh, the one wants the average height of male in India. If a person wants average height of males in India, he cannot calculate each and every person in India their average height, right? It is not feasible, actually not possible. So what can he do is to go in every state and collect around 2 to 3k data of each person, 2 to 3000 per state, and then take the average, and he can draw from that average that as around 20 per 20k people have some height called like 5 feet. So the population, so the around 65 crores India can have, there is a possibility of 90% that they also have a average height of 5 feet. See, so it is the descriptive analysis that we performed on the sample, like we collected the data and plotted in a tabular manner and got the most frequent data, or performed various analysis like mean, mode, variance, covariance, etc. Anything we performed on the sample, and we got the average height, right? And then we inferred that the population must also have a 5 feet height with a possibility of 90%. The thing that we gone from sample to population, the thing where that we gone from sample to population comes under inferential stat. The process of going from sample to population comes under inferential stat. So hint for inferential stat, sample to population relation is given, or uses of word like infer. What do you infer from this data? So it is inferential data. Generalize expected, what is the expected height of male? So it will be an inference that we are drawing for about the population based on the sample. So it comes under the inferential statistics. So let's have a look on this. First descriptive and then inferential. So in the descriptive, the goal is to summarize sample data. We have to summarize the sample data, and then we draw conclusions about the population. And whenever we draw any conclusions, or whenever there comes the fact of probability, it is generally inferential statistics. As we performs operations on sample data, then we conclude about the population. So the conclusion about the population comes under the inferential stat. Now the data scope is can be either whole population or sample only. Consider a test where there are only 100 candidates, so we can calculate score of each candidate, right? We do not need to divide into sample. It is feasible to calculate all the marks of all the 100 candidates. So in that case we will perform stat on whole the population. So it can also come under descriptive. But in the height, but in some cases like the average male height, we cannot conclude each male height in India, so we can take the sample size only. Sample to generalize entire population. It is the general fact that from sample to population it comes the inferential stat. So there is a sample that generalizes the entire population, and this process is comes under inferential stat. Tools, let me see some tools. Tools like table, charts, mean, mode, standard deviation, all the statics that we will be using in the later weeks, or the stat we generally use like mean that we calculated on the last page, and like the table, like the graphs we made on the last page, comes under descriptive analysis. But what we conclude from that table, from that graph, from after doing the statistical analysis, comes under the inferential stat. And there is hypothetical testing, confidence interval, regression, like this is ML model. So it is a probability, right? Now what probability we conclude from the sample, what after making tables etc., comes under inferential statistics. Output is raw data, but here output is probability. See, the average height is 5.6, so we can conclude by 95% chance that the population also have 5.6 feet. So there is a chance, there is a probability. Okay, so this is the basic definition or basic difference. So here we completed the branch of stat. Now we will looking towards the data. So data can be of mainly of two types: structured data and unstructured data. Let me clear out the unnecessary markings here also. So let's look upon some data. See, data can be of two types: structured and unstructured. See, first one is structured data. The structured data, in structured data we can perform statistical analysis on it. Can Statistical analysis can be performed, generally unique, like phone number, email addresses. Like see, phone number or email address is unique for everyone, like see, correct. Like the roll number is also unique for everyone. In a table there is a column known as serial column. In the serial number is unique for every object, right? So these are structured data. and we can perform mathematical analysis, like we can do arithmetic operation like adding two numbers, adding, dividing two numbers, random numbers. So it can be done on unstructured data also, but in unstructured data we cannot perform statistical analysis like finding mean, mod. It will not make any sense, right? Consider a table there are where there are random numbers from 1 to 10. There are 20 random numbers. They are not necessarily integer, they can be any number, but between 0 to 10. So it is a random numbers, right? So if we find their mean, it does not make any sense. We can find the mean yet, but it will not make any sense, right? Because it is not a structured data. What can we infer from that? Nothing. So it is not unique and generally random. It will be unique like phone number, email address, etc. Random like randomly written words or lyrics of the song. Lyrics of the songs is generally random words. They are not unique. See, two song can have same lyrics yet different melody. So two lyrics can be same. So it comes under the structured data, unstructured data. Sorry. We can perform statistical analysis in structured data only, but we can perform mathematical analysis on both of them. But the mathematical analysis performed on the unstructured data will not make any sense. Now the data can be further divided into numerical and categorical. See, data is further divided into numerical and categorical. Numerical data is quantitative, whereas categorical data is qualitative. It depends on the quantity. Numerical data depends on the quantity, like 2 is greater than 5. Sorry, 2 is less than 5. So we can infer this information that 2 is less than 5, but we cannot say bad is less than good. Right, it just they are just word. We can infer for a person, but if we on the scale of measuring how bad a person is, so then in that case bad will be greater than good. So whenever the condition is not given, we cannot infer from that word that which one is greater among them. So it will come under categorical data. And the values like height and weight, the values like height and weight comes under numerical data, whereas the adverbs like more, less, etc. comes under categorical data. Numerical data generally consists of numbers and categorical data generally consists of words. But we cannot infer for every situation, right? Like see, days are generally Monday, Tuesday, so it will be categorical data. For dates, consider 27, 28, 25. We cannot say 27 has greater precedence than 28 or 27 is greater than 28. It will not be making any sense, right? They are just allotted to days. They are the number that are allotted to certain day. So we cannot say a day is greater than some another day, right? So we cannot do this, so it will be categorical. So it is important example. If a person who is not capable of doing the can wrong the question in the examination, so you should remember this example. Whereas the number of days, see, what is the basic difference? 27 doesn't equal to 27, like it is the 27th of April, it is 27 of May. They are not equal. So but by looking number we can say 27 equal to 27, but this doesn't make any sense, right, for the days. That's why they are categorical, not numerical. This is the basic difference I was trying to say. But for the number of days, see, a person waited 7 days and a person waited 3 days. But the person who waited for 7 days has greater waiting time, right? It is making sense in the real world. So the number of days, that is the difference between the days. It makes sense, but not the actual date. Like 27th day is not greater than 28th day, but the number of days between two different dates are making sense, as 27 days is greater than 30 day. We can equate here numerical data, therefore. Now the numerical data, not the categorical one, but only the numerical data can further be subdivided into discrete and continuous. Discrete like 1 to 3 etc. But they are not necessarily integers, like 1, 1.5, 2, 2.5 etc. can also be discrete. But in the continuous data, there are infinite values of data. So we divide these values into intervals. As they are infinite values, we cannot perform any analysis of them. So basically we divide them into interval and then perform the required analysis we want. So 10 to 1 to 10, 10 to 20 etc. To find the continuous data in our questions, there is a tip, like the continuous data usually have a unit associated with them, like kg, centimeter, kelvin, etc., any unit, but they will have a unit associated with them, the continuous data. So for example, a person with 27 centimeter height, so it is a continuous data, because a person, second person can also have 2.02 height, or that third person can also have 0.02 height, basing basis the basis on the precision of the scale we are talking about. But this can be theoretically possible, right? So it is continuous. Now the data, we first divided the data into, let me tell you, we first divided the data into unstructured and structured data, then we further divide into numerical and categorical, then numerical one we further divide into discrete and continuous. At last we are dividing the data into two parts. First one is time series and second one is that cross sectional data. First, the time series data is used when we are inferring about the a period of time, like see, in this table from 1st June to 12th June, there is the data of ozone, temperature, relative humidity, and deaths. See, 1st June to 12th June, there is a period of time, right? So whenever there will be a period of time, there the data will be time series. Whereas in the cross sectional data, we are talking about different places, different region, their rural community, piped water lines, water location, lack of water, anything. But we are talking about different places, but at a particular time, at a particular time interval. That time can be a year, a month, a day, anything, but it will be a particular time, like a particular year. A year can be of various months, but if on a scale of year, it is a discrete number, right? So a particular year can also be there. So a particular time is called cross sectional data. So data we divided three times: first unstructured and structured, then we divide into numerical and categorical, we divided the numerical into discrete and continuous, and now we are dividing the data into time series and cross sectional. Time series means the when the time is period of time is used, whereas cross sectional there is a particular time we are using. Now comes the cases and variables part. See, first one is cases and variables. See, let's look upon the what are the basic difference between the cases and variables. Now let's have a look upon what are cases and what are variables. Then we will be looking upon the scales of measurement, and it will mark the end of week 1. Then we will be looking at some questions, basically all the questions of week 1, except the practice assignment. It will be done in the revision session. So let's start. First one is what is cases versus variables. See, in a tabular columns, in a table basically, and there are two types of things that we can observe. First one is a row, then second one is a column. So every row, see, first row is a name can take various values, right? Like Riya, Arav, Sita, Mohan in these cases. So name can take various values. Same for age can take multiple values, like 17, 18, 17 again, and 19. So and gender can take, here it is taking basically two values in this table. So female, male, female, male. See, in the cases can take multiple values like 1, 2, 3, 4. So they are variables. Variables can store multiple values. See, the variables can store multiple constant values. Like Ria is a constant, but name is not. Name is storing Ria. So there is a variable which can store multiple constant values, and these value will come under a column. See, the name has a separate column, the age has a separate column. So each variable has its own separate column, right? So each case has its own column, right? So every variable has its own column. Now comes the row part. Every row, see, first one, last one is Mohan. Mohan has fourth serial number, name is Mohan, age is 19, and he is a male. So it is a case for Mohan, right? For every case there is a column. associated with them. For every person, for every observation, Mohan is an observation, right? We are observing Mohan. Who is he? What is his age? What is his gender? So it is our observation, or it is our case. For every case there is a column, not a row. For every variable there is a row, like for name, age, etc. For every variable there will be a row. For the In each row there will be multiple constant values, but for each case, for each observation, like Mohan is an observation, for each observation there will be different column. So we can conclude that one row is equal to one case. See, one row is equal to one case, whereas one column is equal to one variable, right? So we can erase these things. Okay, now it is clear. So what did we conclude? That, see, first one, this is a name variable. It has a name called variable and store multiple constant values. And similarly for age and gender as well. For Mohan, there is a observation called Mohan. It is a case. It has several values, like it has his name, its age, its gender, and its serial number or roll number, we can say. So every row has its own case. See, it is a row. Every row has its own case, whereas every column, that is the name, that is the name column, has its own variable, where in this case the variable is name, and in this case, the row 1 case, the row is Mohan. So did you understand? The case, each case has its own column, uh, sorry, each case has its own row. The row, for example, in this case, the fourth row, the serial number is 4, the name is Mohan, the age is 19, and he is a male. Okay, whereas for each row, there is a, for each column there is a variable. For first variable name is name. It has multiple constant values like Riya, Arav, Sita, Mohan. And there is another variable called age. It has multiple constant value like 17, 18, 17, 19. So this was the basically difference between the case and variables. Let me clear them out. Now we'll be looking at the last topic, that is the scales of measurement. See, for measuring something we need some kind of scale. For measuring a capacity we generally prefer a jar beaker, which we measure in ml or liter. For measuring height we measure in a meter scale or millimeter, depending on the size or height. Similarly, for measuring different values we consider basically four scales in stat, and we will be looking each scale in detail. So the way of looking at the scale will be like, first we will see some example of them scale, which will be cleared, which will be picture us about the scale. Then we will see it has on any order or not, and at last we will be seeing that can we perform any operations on them. So basically there are four types of scale. First one is nominal. Nominal scale considers many variables like name, gender, blood group, etc. These have no order and no operation can be performed, right? See, how can you perform operation on names? Like these operations are telling like arithmetic operations. They are suggesting the arithmetic operations. So can we perform any arithmetic operation on name? We cannot add to name to gender, right? So no, there is no order also. A name called Ram is not greater than, is not equal to Mohan, right? Or a Ram is also not equal to Ram, as there can be two person with same name, right? So there is no order, no operation can also be performed. And see, it is the basically nominal scale. It is the quite simpler scale to understand. The middle of the two are the one who which consist of confusions, so we'll be looking more about them. For second one is ordinal scale. Ordinal scale is basically a type of categorical data only, where we give like ratings or ranks to something, like on a scale of 1 to 5, how I like the food. it comes under the ordinal scale. See here, 1 to 5 is a number, so you can consider it as a numerical data, but is a categorical, because we can say that 1 is greater than 5. 1 is greater than 5 for how bad a food is, but 1 can be less than 5 for how good a food is, right? So based upon the situation, when 1 can be greater than 5 or 1 can be less than 5, it doesn't follow the thing like 1 will also always be less than 5 according to the numerical data. It will be incorrect for that case, right? It was same as saying that 27th day is less than 28th day. This operation is not possible for categorical data. It is same as saying the rating for the food in a restaurant too. So the rating or ranks given comes under the ordinal data, as it is a part of categorical data. Both ordinal scale and nominal scale comes under the ordinal categorical part, whereas the later two scales comes under the numerical part. So for looking at the ordinal scale, the things like rating or rank and the adverbs used like average good. Whenever we say the food was average or the food was good, we are considering it as an under ordinal scale. See, it has a order, right? We can say that average is less than good in any case, right? So it has a order, but we cannot perform any operation on it. See, average is greater than is less than good, unless good is less than excellent, right? But we cannot say anything about average minus good. We cannot say average minus good is bad. So it is not the case, as it is not a numerical data, it is a categorical one. So we can, it has a order, but we cannot perform operation on them. So basically the difference between nominal and ordinal is a fact that if the first one doesn't have any order and the second one has, the later one has a order. So basically it is the difference between nominal and ordinal scale. And now comes the interval one. Interval, as its name suggests, whenever the data given in numerical and in interval form like 20 to 30 etc, in that case interval scale is used, and the temperature like Fahrenheit and Celsius, not the Kelvin one. Kelvin one is the absolute scale, but the temperature in Fahrenheit Celsius comes under the interval scale, as we will be seeing later why it comes under the interval scale. Like see, numerical data when division is not possible. It is the numerical data in the interval scale. The data that comes are numerical data when the division is not possible. And as they are numerical, they have a order, right? As they are numerical, we can say 2 is less than 3 in this case. First, for the ordinal, we could not say for every case, but we can say that average is less than good. It is the basic fact, right? And basically in the ordinal one, we cannot say the food rating for 5 minus 1 is 4, right? We cannot say this, as it is a food rating, not a number. So whenever the rating will be represented in a number, but it does not represent a number, right? Like 5 is greater than 1, so a food rated with 5 will be excellent, but a food rated with 1 will be worse. We know this fact, but we cannot say 5 minus 1 will be 4, right? So this will come under the ordinal scale. But for the later, one, here we can say that 3 minus 2 is equal to 1, right? So it will come under the interval scale. Basically not an interval, like here there is an interval 20 to 30, but 3 minus 2 is not an interval. So first we will look at it like this. Operations, what operations we can perform. The first two scale we could not perform any operations, nominal and ordinal one, but in this case, but in the uh, interval scale we can perform two operations, plus and minus, but the ratio cannot be taken. This is the difference between the interval scale and the later scale. We will be studying the ratio scale. This is the basic difference. We can not perform ratio on this scale, and to take the ratio one, another scale was developed, which is known as ratio scale. So see, proper interval must be defined. See, this is the red mark, so it is important for the examination purpose. Proper interval must be there, like less than 20 and 20 to 30 and more than 30. There will be a data given as like this. The person can think that it is an interval data, but it is not. It is not the case, because less than, we do not know what is the lesser part. It can be 0, it can be minus 20, and same for the more part. We cannot say what is more than 30. 50 is more than 30, whereas 40 is also more than 30. So there is not a definite interval, right? So in that case, it will come under the ordinal scale. Remember this fact. Whenever will be no interval, it will come under the ordinal scale. We try to degrade the scale always. Like, see, if we upgrade it to ratio scale, then we can say that it is a ratio scale, but we cannot perform any ratio on them. It will be useless, right? So we try to downgrade the scale whenever possible. Like in this case, there is no proper interval, so interval scale is not possible for it. So it can be upgraded or downgraded. We try to downgrade it. So the operation, in the case of operations, we can perform certain operations, like we can subtract or add them, but we cannot take the ratio. So ratio will be failed in that case if we upgrade the scale. So we downgrade it to ordinal, right? And at last we'll be looking at the ratio. See, these two, ordinal and in interval, were hard basically, and nominal and ratio are easy always. So height, weight, age, temperature in Kelvin. See, absolute temperature, it comes under ratio 1. This is the important fact that you should know. Whereas the height, weight, we can subtract 2 height, we can take division of 2 height. Basically the various things that we observe in day to day life, the numerical data, generally comes under the ratio, unless it is given in an interval. They have a order, and we can perform all operations, plus, minus, multiple, divide, all the operation on the ratio scale. So they are a bit confusing, so I am recalling all the things that we have studied so far. First one is the nominal scale. In the nominal scale, the things like name, gender, blood group, or basically all the categorical ones comes under the nominal scale. They do not have any order, and no operation can be performed on them, right? The second one comes the ordinal scale. In the ordinal scale, there are moreover some categorical data, and we can use some numbers for rating purposes from like 1 to 5. And in that purpose, the 1 will be greater than 5. Let me erase this. This can confuse you a little bit. We can say 1 is less than 5. See, let me erase this part also. uh, huh. We can say here 5 is greater than 1, as 5 is the best rating and 1 is the worst rating, but we cannot say that 5 minus 1 is 4, right? So it is the basic difference. We should conclude everything about it if it is a number, but we cannot conclude everything. So it is the basic difference between it. So 5 minus 1 is not 4, but we can say the 5 is greater than 1. So it is not either nominal data, but is not also numerical data. So it comes under the ordinal one, ordinal category. Like if we rate the food from A to D, where A is the least favorite and D is the most favorite, we can say A is less than B is less than C. So it has a order, but we cannot perform that A minus C will be B. It will be false, right? Same for number also. It has a order, like 5 is greater than 4, but we cannot minus subtract 5 minus 4. So it is, as it is a categorical one. So it has a order, but no operations can be performed, and then basically used in rating and rank purposes. Then comes the interval part, the interval data. The temperature in Fahrenheit and Celsius is an important thing to note. Important. Whereas the numerical data where division is not possible, it is the basic order. They have a order and we can also subtract them. Both are possible, but in the earlier case it was not possible. So it comes under the interval scale and not the ordinal scale. This is the basic difference between interval and ordinal. And the operations we can perform is all except the ratio and the multiplication also, as it is the reciprocal only. So operations like plus and minus can only be performed. See, plus and minus can only be performed, and not the multiplication also. Remember that. Proper interval must be there for or for a thing, for a data set to fall under the interval scale. A proper interval must be there. If it is not, it is downgraded to ordinal scale. Okay. Now comes the easier part, the ratio one. Ratio one is very easy. The simpler thing, that the simpler numerical data that we see around the world, like height, weight, age, etc., comes under the ratio. It has a order and all the operations can be performed on it. So this marks the ending of the week one. Okay, it was quite fast, so try to watch this lecture 2 to 3 times in the recorded format. And it is not actually, I have tried to summarize it in simpler manner, and all the things are covered in this video. You do not need to look around any other resources other than this. You can practice some questions from the graded assignment as well, but for the theory purpose, this is enough. So let's do some questions of week one. Let's start from last, as we have studied the scales of measurement. It will be refresher for us. So now let's have a look. See, a courier service is interested in knowing the customer feedback. The customer being given the following option to choose from. Actually, I had done this in the class, so that's why it is marked. So ignore the markings. Just try to understand with me how this answer came for all the answer in this PDF. First one is not satisfied. See, it has a order, like not satisfies least and very satisfies the most. But the data is in category also. It should fall under the ordinal. So that is the case. Second one is the order and rank is meaningful. Except the nominal data, in all the three cases, the order is meaningful, right? So ordinal ratio, matlab see, ratio, interval, and ordinal scale, interval scale, except the nominal order collect. And see, here is the example I was talking. Less than 30, more than 60. One can think interval, but the answer is ordinal. Now comes the case. See, what can we say about the scales of measurement? Scales of measurement when used in measuring. Oh, we can erase. So let me erase them. Let me see. Uh, Let me erase the answer part. Hmm. What can you say about the scales of measurement is used to describe the hair color? Blonde, brunette, red, or black. See, red is not greater than black or anything else. So there is not a order, or we cannot perform any operation on them. As it has no order, so the scale must be nominal only. The answer should be nominal. Now, the scales of measurement of mobile number. See, for phone number, there is no order. The number starting with 8 is not greater than the number starting with 9 in a phone number. So it has no order, right? So as it has no order, so it is a nominal data. And as nominal and ordinal are categorical data, categorical. So a phone number is also categorical. Phone number is also categorical. See, the addition subtraction can be performed the variables. In which variable we can perform the operations like addition and subtraction. It is not telling about division. So there are last two scales, the ratio one and the interval one. These two are for categorical, so we cannot perform any operations on them, right? And now comes the later part, the ratio scale of measurement. Let me write it down here. In the categorical, there are majorly two scales, nominal and ordinal. And for numerical, there are two scales, Basically interval and ratio. I will give you the updated PDF, so don't worry. See, the variable in ratio scale, addition is possible, subtraction is possible, multiplication is possible, and division is possible. And the variable of measurement can have zero, one of its value. At first glance, we can neglect these statements as the division is possible, so we know that denominator cannot be zero. But we can say that there is a high there. We have seen some height like 0 centimeter or 0 Kelvin. It is a theoretical value, but we have seen this, so it is also possible. But we cannot divide in that case, so it will be a case where division is not possible, but we can say that value is possible. We cannot perform operation on it. It is another fact, but we cannot say about the existence of that variable, right? So 0 is possible, but we cannot perform the operations like division on it. It is the fact. Now comes another part. um, in order to forecast the tomorrow's temperature in Mumbai, the Indian Meteorological Department collects temperature and humidity and rainfall data of Mumbai of all days from past 3 months. See, there is a period of time associated, right? So it will be a time series data, not the cross sectional data. Now comes another part. What kind of variable are comparative forms of adverbs? Adverbs, whenever adverbs it is categorical, not numerical, right? Day and date. See, day and date. We have seen in the example that day and date are not numerical, rather categorical. So categorical will be answer. Here we can be mistakenly mark as numerical, but remember this fact. What kind of variable is latitude? See, latitude, for latitude we can say a latitude of 20 centimeter. It is not it is likely unfeasible, but consider is that as a hypothetical example, like we can consider a height of 20 centimeter, and as it has a height, so it has a unit. It is a numerical data, right? It is not a categorical one. See, so it is a numerical data, and as it has a unit, so it will be continuous, right? I have taught you it will be continuous. And by logic also we can say that one can have 20.1 centimeter, other can have 20.2 centimeter, and the third one can also have 20.15 centimeter. So it is endless, right? So it is numerical as well as categorical data. Numerical as well as categorical data. Now comes another part. During Great Depression, several countries across the world experienced a rise in rate of unemployment. The unemployment rate between the years 1929 and 1942 in US recorded the monthly basis. See, monthly basis, and there is a time. The time between 2019 to 40. Therefore, the data will be time series, a period of time, right? Now, a day, the number of day as a group student take to finish a school project is, see, the number of day can is also discrete. One can say a student done its project in 1.5 day, but it is unfeasible to say that a person has done the project in 1.667 days, right? It is unfeasible to say. So it is not a continuous. There are not infinite pieces of days. A person can say it has completed his project. One can either say it has completed his project on one first day or second day, right? So it will be discrete, and it is quantitative, not qualitative. As it is a numerical data, so it will be quantitative, right? So we are done. And now comes the seventh question. The kind of variable is a qualification of candidate. See, for the qualification of candidate we need a qualitative data, not a quantitative. We know we do not need a number of candidates, but we need a single candidate with various qualities, so it will be qualitative data. And as it is a qualitative data, it will be categorical, right? Suppose the eighth question, suppose one is interested in calculating the weight. See, weight, here comes the weight, and as it is a weight, it will be a quantitative. It will be a quantitative data, and also as kg it will be continuous, as it as a unit it will be continuous. So quantitative and continuous data. See, we are done for most of the questions now. Okay, it is the last part. See, let me remove all of these. See, identify the sample and population from the given statement. A sample consists of student of all across India. See, and the population consists of student from urban areas. It is a wrong statement, right? See, state sample will be always less than or equal to population. If the sample is greater than population, then what's the purpose of taking sample? We are taking sample so to decrease the data set of our own, and the taking the average of the heights. In our example, we took the sample of around 30k males for 64 crore male in India. So what's the purpose of sample if it is greater than population, right? So here in this question the sample is all across India, but the population is only urban, so population is less, so it will be a wrong statement. Second one says that the sample consists of a student in urban area and the population consists of a student of all across area. See, here the sample is less than population, but either in this way the option is incorrect in this case also. Why? The sample is biased here. See, the sample only consists of urban area, whereas the sample consists of the student of all across the country. So, sample is biased here. The sample should be of urban and rural both, but it is of urban only, so it is a biased sample, so it is also a wrong statement for a sample, for an ideal sample. Sample consists of student of urban area, population consists of selected 10,000 only. See, here also sample is greater than population, so it is a wrong statement. And the last one, the statement consists of 10,000 people in urban area, the population consists of all across. See, here sample is also less, and it is a biased sample in this case also. It is not a completely right statement, yet here the sample is less than the sample is less than population. This condition satisfies, and the most correct option in these options are option 4, yet not completely correct but most correct. Here the sample is biased also, that's why. Identify the correct observation. Let me remove these. See, affirmation conclusion made basis on the sample is correct. It is wrong. Its sample is biased, it cannot give correct results. As we have seen in the fourth example, the sample was still biased, right? So it cannot give correct results, so it will be wrong. So none of above is also wrong. The sample is good representation of population, incorrect. The second option, the conclusion is not correct because the sample is not good representation of population, correct. It is not a it is not a representation of a population in this case, as the sample is only consisting of the person in urban area, not about the rural one. Okay, now comes the third option. What kind of nature of study is this? See, here we are going from sample to population, and whenever we go from sample to population, I have said the study will be inferential and not descriptive. So inferential, not descriptive, both are the correct options. See, whatever the question is given, see the last part, between 20,000 to 40,000 users are expected to opt in the project. See, this is the inference we are drawing. We have took some analysis, it is not required, but at the last part we saw that expected, the word expected is here, the probability. Whenever I said that, whenever the objects like the words terms like expected, probability, etc comes, the study will be inferential only. So the inferential is correct option. Delhi Pollution Control Board wants to check the AQI for major cities after Diwali to decide if the air pollution is reaching unhealthy levels. To do so, they have came upon a list of major cities and respective AQI levels. Okay, and want to determine which city among the list have an AQI greater than 100. Okay, what kind of statistical analysis? It will be descriptive, right? We are not drawing any inference. We are not saying that Delhi was the one with highest pollutants, therefore the, let's say, the average age of the males are low. So we are not drawing any inference, or we are not talking from sample to probability population, or we are not talking about some probability. We are just taking the table, and we are just making assumptions about the cities of 100 AQIs. So it will be descriptive. Now, suppose we are interested in studying the height of average Indian male adults above the age of 18 due to practical constraints, right? It is not possible to collect the data of whole country. So we decided to took a sample of 10,000 people. Which of the following choices for the sample do you think is most representative of the population? Okay, let me see. The sample consists of 10,000 people from Karnataka. Okay. The sample consists of 10,000 women from South India. We want a good sample, right? For the average Indian male adult, not a regional male adult. So we are trying to take a sample for whole India, not a state. So these two are incorrect. The sample of 2,000 from each part of India, it will be correct, right? From each part, the consists of 40. Here the weight constraint not required, so it will be incorrect. Now let's have a look upon the next question. Find the following statement best describe the difference between the population and the sample. Sample and population are synonym to each other. Incorrect. A sample is entire group while population is subset of sample. It is vice versa is true. Population is entire group while the sample is subset of the population which is used to describe the parameters of population. Correct. Population is all the member of organization where the sample is the member of organization who volunteer to participate in the study. Uh, Basically what it's saying is the third option is population is entire group while sample is a subset of group which is used to describe the parameter of population. This I guess is correct. And the fourth option is telling us that population is all the members of an organization is a while sample is a member of organization who volunteer for the study, right? So in this case, the D option will be incorrect. The reason is the fact that population is the all the member of organization where the sample is the member of organization who volunteered to participate in the study. So the in this case the population can be biased. It is not telling just they want to participate in the study doesn't mean about they will be correctly representing the population. For example, in our first case, in our last question, if the people of Karnataka and South India are only people who are available for the study, doesn't mean that we will take the sample of these two states only, right? So we have to take the sample for whole India to represent a correct population. So it is not a correct option as they are a volunteer, they will be participating, but the diversity of sample is also required. Otherwise a biased sample can give a biased results. According to International Cricket Council, a test cricket ball when new should not weigh more than 136 gram, right? The manufacturer of Duke cricket ball suspected that the average weight of their product is more than 160 gram. To confirm the 100 Duke ball were selected. Based on this, choose the correct option. Okay. Population. What is the population? One can say simply the cricket balls, but it will be wrong. The population is all cricket ball, wrong. because in this case the population should be only duke balls. We are concerned about the duke balls only. So the population is all duke ball, the sample is 100 duke ball. It is the correct option in fact, and this is also wrong as it is saying all duke balls. So remember, try to read the question in a good manner. So duke cricket ball will be the population and not the all cricket balls. 10th question is that a director of engineering institute wants to evaluate the performance of student of all years of all departments. Okay, in the institute, he randomly selects performance report of 50 students from first year computer science batch. Based on this, choose the correct option from the below. Okay, he randomly select the performance report of 50 students of first year computer science batch. Okay, so what is the sample? It is asking, right? So the sample should be chosen as collectively randomly. And the sample chosen is correct as it is collected randomly. He randomly select performance report of 50 students for first year. See, it is telling of first year only. Okay, but the population is of all years of all departments. It is telling about the first year of only computer science. So the sample must be wrong only. So right, they will be incorrect. The two are wrong as it is not collected randomly. It is not representation of entire population. So what is the option? It is actually, in your opinion, it is the fourth option as it is not representing the entire population. It should be our first priority. It is not collected randomly. It should be not collected randomly. In fact, consider in a random chance, all the 50 students are from computer science batch, CS batch. So is this sample right? It is wrong. So it should would not be complete collected randomly in the first place. So it is also wrong. It should represent an entire population. It should be the right case. So we are done with the questions, I guess. Oh, there is another one, another page. So let's have a look upon this quickly. First one is the about the structure data of spreadsheet. Each observation must have its own row. Observation is nothing but case. Yeah, we saw that each case has its own row and each variable has its own column. So it is right. Each variable must have its own column. Also right. For each variable of same type, values of cases are recorded. See, for each variable, like a variable called name, there are several values like Rima, Sima, etc., Ram, etc. They are the cases. Ram was a case, right? Mohan was a case, right? So for each variable, there are several cases that are recorded. So it is correct. So last one will be indirectly incorrect as the first one is correct. The data lyrics of song, it is unstructured. Okay. See, the data collected from several people of every family in a locality, the collected information is first name, second name, income, height, etc. Which one is not a variable? See, a thing is not variable only if it has multiple values, multiple constant values. But all these have so not a variable. So a thing is not a variable if it is constant. So all these are variables, but only locality is constant as the person is living, the family is living in a simple locality, in a locality. See here, in a locality. So the locality is constant for all them as the locality is same. So it is not a variable. What is saying temperature and relative humidity? Okay. uh, See, the temperature and humidity graph is given to us and we have to tell about something. So let's have a look. In the table there is a temperature, time and relative humidity. See, these are the cases as they are a row. So these will be cases and these are variables: time, temperature, humidity, right? These are variables. So temperature is a case, wrong. Temperature is not a case, it is a variable. Temperature is a case, wrong. Time is a case, wrong. Relative humidity is a case, wrong. They all are variable, whereas these are the cases. Time slots are the cases. Okay. Unstructured data, see, unstructured data he's asking. Phone number is not unstructured. In email is not structured as they are unique. Image file to images file can be same to video files can be same to website in fact can be same, as we usually make dummy websites in our practicing period, so they can be same. So these three are unstructured data. What statement are true? All structured data have units. See, yeah, the serial number is a structured data 1 to 8, but it doesn't have any unit, so it is incorrect. Comments in a structure social media are structured data, also incorrect. If they are unstructured data, they are just random words. Unstructured data cannot be used directly to perform statistical analysis, correct. And a mathematical operation can be performed on unstructured data. It is also mm, see, unstructured data cannot be used for performing statistical analysis. It is correct, as we have to make the data first structured for doing any operations, right? But for the fourth option, uh, about the fact that can we perform any mathematical operations on them or not, and as we know from the fact that structure mathematical operations, they are numbers, so we can perform on them, right? So but consider a fact when there is not some numerical numbers only, there are categorical ones also, like a b randomly c d. So in that case we cannot perform mathematical operations, so it will be wrong. It was a tricky one. Basically, it depends on the thing that if a numerical data, then we can perform mathematical analysis, but it is telling about general purpose. So in general, if the data is unstructured or the data doesn't have the numerical part, only the categorical one, then we cannot do mathematical operations on it. Okay, consider this table. The table is structured, always the data is structured 1 to 8 serial number wise. Okay, identify the name and observation. Observations are cases. What are variables? See, serial number, name, gender, favorite artist, and amount of time. These are variables. So name is observation, incorrect. Name, gender, amount, these are variables, correct. Name of the student and name are variable. Student is a observation. Each student is a observation. See, every student has its own name, it's female, its roll number, and its age, time allotted. So it is a case, not a variable. So each student is a case. So both are correct. So and the last question is that the amount of time Akash spends on painting is 0 hours. So let's look on the table. Where is Akash? Here is the Akash. He is a male, and the amount of hour is not given in the table, right? It is not given in a table, so the first statement should be wrong. It is not 0 hour, we have not given the table. We cannot make any conclusion about the cast because data is not available to us, correct? So statement 2 is correct, but 1 is incorrect. So all the questions are done. I hope you understood the week 1 quite well, and if you have any doubts, so let me, we will be clearing in the doubt sessions and the live class upcoming. So stay tuned, and thank you for the lecture.